Welcome back to Physics from 4 KSSM. So we'll continue to topic 4.4, gas laws, on topic Charle's Law. Okay, before we discuss Charle's Law, we want to discuss about absolute temperature. What is absolute temperature? The temperature that measured in Kelvin scale. We call it absolute temperature. So the Kelvin scale of temperature K is just like Celsius scale. 0 Kelvin is absolute zero. 0 Kelvin is equivalent to negative 273 degrees Celsius. This one determined from the experiment that we will discuss later. Why we need to discuss about absolute temperature or temperature in Kelvin? Because gas law is valid. The gas law is valid by using this temperature in Kelvin scale. So you look at here, this picture shows how Celsius scale is related to Kelvin scale. Meaning if given temperature in degrees Celsius, we can convert to Kelvin. Or given in Kelvin, we also can convert to degrees Celsius. Get this picture. So 0 Kelvin is equivalent to negative 273. 0 degrees Celsius equivalent to 273 Kelvin. 100 degrees Celsius equivalent to 373 Kelvin. As you can see here, negative 273 plus 273 equals 0. 0 plus 273 equivalent to 273. 100 plus 273 equivalent to 373. Thus, we can have a formula to calculate. That is, when you want to convert a temperature in degrees Celsius to Kelvin, what you do, you just add with 273. Or you want to convert from Kelvin to degrees Celsius, you just minus 273. Look at the example here. Let's say 30 degrees Celsius, you want to convert to Kelvin. So you just take 30 plus 273, so equivalent to 303 Kelvin. Or 313 Kelvin, you want to convert to degrees Celsius, so you just take 313 minus 273, so you get 40 degrees Celsius. Okay. So what is absolute zero temperature? Absolute zero temperature or 0 Kelvin is the coldest possible temperature. It is a temperature at which all movement stops, or you can say the molecules also stop moving. So like freezing, okay, or become stationary. Scientists have made temperatures very close to absolute zero, but it is thought that absolute zero can never be reached. So what we get from the experiment is just by extrapolation of the line of the graph. So just by theoretically we can get the value, but practically we cannot get exactly 0 Kelvin or absolute zero temperature. It's a very, very cold, which all molecules stop moving. Okay, now we want to relate between volume and temperature of gas. Let's say we have an empty plastic bottle. Inside there's air. So we place into the freezer of the refrigerator. So what happens to the volume of air in the bottle? So you can see here what happened to the bottle. It crumpled or become change in shape. So this is due to the volume of the air that reduced due to the reduce of temperature. So from here we can see a general relationship between volume and temperature, meaning as temperature decrease, volume decrease. Okay, look at here, we have a Charle's Law simulation here. So we make it pressure constant. Same thing as the Boyle's Law. We discussed pressure, volume and temperature. So in this topic, Charle's Law, we discuss about volume and temperature, meaning pressure is constant. So you look at the pressure meter here, 1.5, meaning constant. So what we do, we have a container contains molecule of air or gas. So we put load here and the piston able to move up and down. Okay, then what happened is we supply heat. When we supply heat, the temperature start to increase. When temperature increase, the molecules will move faster or increase its kinetic energy. Now it will cause the piston to be moved up, or we can say the volume of the gas or air increases. So from here we can see the graph that we get. As temperature increases, volume increases. A straight line pass through origin, that one shows that volume is directly proportional to temperature, but temperature must be in Kelvin. Okay, here we get the volume of gas is directly proportional to absolute temperature, or temperature must be in Kelvin. Okay, now in your textbook you can refer experiment 4.5. This experiment is to relate between temperature and volume of gas. So inference, temperature of gas influences volume of gas, or you can write volume of gas depends on temperature of a gas. Hypothesis, the higher the temperature, the larger the volume of gas. Aim to determine relationship between temperature and volume of fixed mass of gas at constant pressure. So we have three variables here. So as you can see, for Charle's law, it discusses about volume and temperature, meaning the other one, pressure, must be constant. And of course, mass also constant. Okay, so you have manipulated variable, temperature, theta, responding variable, volume, V, represented by length of column of air, L, in capillary tube. Constant variable, pressure and mass of air. Apparatus and materials that needed, capillary tube containing air trapped by a column of concentrated sulfuric acid, 500 milliliter beaker, thermometer, ruler, Bunsen burner, tripod stand, wire gauze, stirrer and retort stand, water, ice and rubber band. Okay, so you can see here, this is the capillary tube. So we tie with a rubber band to the meter rule. And then you can see inside there's a small column of concentrated sulfuric acid. This one is to produce a closed container of gas or air inside. So because we want to make it mass of air constant. So here we have a constant mass of air inside. So the length of the air column that trapped by the sulfuric acid, we mark as L, capital L, length of column of air. Okay, now the setup of apparatus. So what we do, we just clamp the capillary tube with meter rule to the retort stand and immerse into the water in the beaker. So thermometer used to measure temperature, and we have a Bunsen burner to supply heat. Okay, so we also have a stirrer to steer the water in order to produce uniform heating in the water. So at above here we put ice. This one is to prevent heat loss to surrounding. Okay, so what we do, when we turn on the Bunsen burner and supply heat, temperature will start to increase. So we can set the initial temperature at 30 degrees Celsius. So we just measure length of the air column, how many centimeter, and record here. So when the temperature increases to 40, you record length of column of L, and then you repeat the same thing by increase of 10 degrees Celsius until 80 degrees Celsius. So you record all the values of L. Okay, so from here we can plot a graph, temperature or length of air column against temperature. So the length of air column represents volume of the gas. Okay, let's look at discussion. Why must the water be continuously stirred while being heated? So the purpose is so that the heat will be transferred to the whole water uniformly. So you will have a value, accurate value of temperature. So number two, what assumption need to be made so that length of the column of air trapped in the capillary tube can represent the volume of the trapped air. So there has a keyword given here, volume equivalent to L times A. So what we do, we assume a constant diameter of capillary tube D is used throughout the experiment. Thus we have volume directly proportional to length of air column trapped. So when A is constant, so we can get how to calculate A. So from here we have pi D divided by 2 squared. So meaning D constant, so we have constant A. So when A constant, V directly proportional to length of air column. Thus length of air column can be used to represent volume. So from this activity, we have a data, then you can plot a graph to get the relationship between volume and temperature. So you can see here, if you plot volume, or the volume is represented by L in unit of cm. So you have this point distributed like this. Okay, so V against theta in degrees Celsius, you get an increases linearly graph. So what you do, you extend the line until intercept at V equals to 0. So at V equals to 0 here, intercept at negative 273 degrees Celsius. So V0 means the molecules of gas stop moving, meaning this point we also state as the absolute temperature, where the molecules all become stationary. Okay, so if we convert the graph V against temperature in Kelvin, so meaning we have the graph, a straight line graph passed through origin, so we can get V is directly proportional to absolute temperature. So T is absolute temperature. So what is stated by Charle's law? So Charle's law states that volume is directly proportional to absolute temperature for a fixed mass of gas at constant temperature. So V directly proportional to T, or V equals KT, where K is constant. Thus, the ratio of volume and temperature is equivalent to constant. So we have two conditions. So the condition 1 we mark as V1 divided by T1 equals to K, and V2 divided by T2 also equals to K. Thus, we have V1 divided by T1 equivalent to V2 divided by T2. So this is the formula used to solve problem involving Charle's law. So back to the PVT triangle. So this Charle's law just discussed about V and T. So you just cover the P, meaning P is constant. Thus we have V divided by T equals to constant, or V1 divided by T1 equals to V2 divided by T2. Okay, now we look at some of the problem solving. So the sample problem 1, a gas sample at 40 degrees Celsius occupies a volume of 2.32 liter. If the temperature is increased to 75 degrees Celsius, what will be the final volume? So you can see when you read through the question, no mention about pressure, meaning pressure is constant. Thus we know this question is about Charle's law. Okay, so straight away you can write the Charle's law formula and then you substitute. Remember, for the Charle's law states that volume is directly proportional to absolute temperature. So meaning the temperature must use unit Kelvin. So if given in degrees Celsius, you must convert to Kelvin. If not, your answer will be wrong. Okay, let's look at here. 40 degrees Celsius, you convert to Kelvin, so you just plus 273. 75 degrees Celsius, convert to Kelvin, you just plus 273. So you get V equivalent to 2.54 liter. So no need to use the SI unit, because both sides the unit will be cancelled. Okay, number 2, an air bubble has volume of 1.2 cm cube at temperature of 27 degrees Celsius. What is the volume of air bubble if temperature increases to 47? Same question here. So you need to convert temperature, degrees Celsius to Kelvin. So use the formula that states by Charle's law. You substitute, then you get V2 equivalent to 1.28 cm cube. Okay, so this sample of the problem. So we have more types of problem on Charle's law. So you must go and do more exercise on this. So that's the end of this topic, Charle's law. So do subscribe, like and tab for more oncoming videos. Do support physics teacher. That's all.